What's the difference between IT security and OT security? Why is it so important to have a solution that is able to identify threats across those different areas of your enterprise? In this episode, we are going to talk about Azure Defender for IoT and how it fulfills this gap. Stay tuned, we'll be right back. Welcome everyone to Azure Security Center in the field. Before we start today's episode, I want to remind you to subscribe to Microsoft Security channel. Make sure to hit the bell so you get notifications when we upload new videos. Go to aka.ms/ASC in the field and you see a playlist of all episodes that we released. With that, let's get started today. I have a very special guest that is going to talk about a very interesting subject. Phil Neray, welcome to the show.
Thank you, Yuri. Great to be here.
Absolutely. So I'm glad to have you here. Can you tell a little bit more about yourself, what you do for Microsoft, the areas that you are working on right now?
Sure. So I'm the Director of IoT and Industrial Cybersecurity at Microsoft. I came in about 9 months ago through the acquisition of CyberX, which was a company that was one of the early innovators in the field of IoT and industrial cybersecurity. And I've been in the technology world for about 20 years now, having worked for other companies like IBM Security, Veracode, and Symantec.
Awesome. So we are with the right person to talk about this subject. And before we even go to the Azure Defender for IoT subject, let's step back a little bit, talk about IoT security. What are we really trying to resolve here?
So IoT security is a very broad area, and it encompasses a domain called OT security, or operational technology security. And you may have read about this recently in the news with the hack of a gas pipeline. But what we're talking about with OT security are the devices that manage physical processes like turbines or industrial robots or mixing tanks. And this is a relatively new area for security professionals because in the past this wasn't an area that was focused on. But the reason it's important is because the risks involved in OT security are much different than the ones in IT security.
Mm-hmm. Yep. This slide that you presented defines pretty well. So thanks for that. What is really the difference between IT security and OT security? How could you differentiate both? Mainly because when you are adopting this solution, there are different personas that will be managing security for IT and probably personas that will be managing security for OT.
Yeah, so there are a number of differences, but in the end, what we're finding is that security organizations are responsible for the OT security as part of their enterprise-wide responsibility. And so what's important is for CISOs and CISOs teams to understand the differences so they can work with their counterparts in the factories and in the places that are using this technology. So one of the very first differences is that whereas IT security is primarily focused on preventing leaking of data, in the case of OT, the primary priorities are about safety and availability of the infrastructure. The other things that are different is that OT security incorporates many types of different specialized protocols. Like you may have heard of Modbus, but there are probably over 100 different ones. Siemens S7, GE SRTP, and these are built upon IP as a foundation, but then the upper layers are quite different. And the devices are also very different. They often have proprietary real-time operating systems. You can't install agents on them. And even when they have Windows systems for managing and monitoring them, they tend to be older Windows systems like Windows XP, just because it can be very difficult to upgrade these systems in the field. These networks were traditionally air-gapped. They were completely separated from both the IT network or the business network, and the internet. But that's changing now with digital transformation. You can think of a very simple example. If you have a factory, it needs to be connected to the SAP system to get information about what's being produced or to provide information about what should be produced. And then with the internet connectivity, we're putting in more sensors and more devices to collect real-time intelligence. So they've traditionally been air-gapped, but because of that, there wasn't a lot of attention paid to implementing some of the security monitoring tools that we've become accustomed to in the IT network. And the result of that is that security organizations today have very little or no visibility into their IoT and OT risk. And that translates directly into three types of business risk. The first is financial risk. We've all seen companies that were shut down, their factories were unable to produce what they were supposed to produce because of malware or ransomware. So there's many examples of that. The second risk is theft of sensitive intellectual property, because a lot of the information about your manufacturing process or the recipe or formula that you're using, if you're a pharmaceutical company, is stored on the OT network. And you can see here a statistic from the Verizon Data Breach Investigations report saying manufacturers are much more likely to be attacked for theft of IP. And then finally, but really most importantly, if you've ever been in a factory, you'll see they talk about their safety record. Their annual reports talk about their safety and their environmental record. And these are all real attacks that we've seen in the past on the grid, gas pipelines, maritime ports, petrochemical facilities that resulted in a safety risk. And so the risks are also quite different in this space compared to in IT security.
That's great. Excellent overview. I think this helps a lot our audience to understand the difference. And we are bringing this solution, Azure Defender for IoT, to fulfill this gap. But the first thing that a lot of customers, they ask right out of the bat is, how are you going to solve this if usually IoT device, you're not going to be able to install an agent? So is this solution based on an agent? How it really works? Do you have an architecture diagram that you can show how the solution works?
Yeah, let me show you the architecture diagram. Essentially, it's a network-based solution where you connect to a network switch, which would be a network switch in your OT network that has the traffic going through it. And you connect to a span port on that switch, grab a copy of that network traffic, which is a technique called passive monitoring or network traffic analysis. This is very important because the people that run the factories are very concerned that you might scan the network or that you might in some way make the network unreliable by injecting traffic. So here you're not injecting anything. The traffic is going only one way out of the switch into this appliance, which is what we call a network sensor. It can be a virtual or physical appliance. It's a standard Intel-based architecture system running our proprietary behavioral analytics and also being enriched by proprietary threat intelligence about the space. And so these analytics then do deep packet inspection on the traffic up to layer 7 and extract information about the assets, the vulnerabilities, and the threats, which can then be displayed on either an on-premises console, because some of these environments need to stay completely on-premises. For example, you can imagine a nuclear energy facility has to be completely on-premises. Or if you want to get the benefits of the cloud in terms of scalability and simplicity and cloud-delivered management, you can connect it to Azure using Azure IoT Hub. And then you can forward the alerts to Azure Sentinel out of the box, or also to a number of third-party SOC tools out of the box like Splunk, QRadar, and ServiceNow.
So this interface on this diagram, I'm just going to continue on the diagram for a second. When you say all the vulnerabilities and threats will be streamed to the Azure Defender for IoT, is this dashboard the dashboard that we know today for the Azure Defender with the same Azure Security Center experience, or there is a different dashboard for that?
It's in the Azure portal, but it has its own dedicated dashboard just because the types of information that are being shown are often quite different. It does integrate with Azure Sentinel, obviously. So from an Azure Sentinel point of view, you'll still see the alerts shown in the graph view, and you can dive down into them just like any other alerts that you would be investigating.
Got it. And so we can say that the experience from the end user is very seamless, right? There is no agent installed, there is discovery, and then from whoever is managing the solution will either manage from the dashboard itself, Azure Defender for IoT dashboard, or if it just wants to consume the alerts, can go straight to Sentinel.
Exactly. And usually we see a hybrid. We see, for example, some of the people in the plant might be monitoring the alerts related to operational issues, like if equipment has been misconfigured or is malfunctioning. Those alerts will typically stay at the plant level because they're more operational than cyber. But then typically what our clients will do is they'll forward all major and critical alerts into their SIM because they need to be investigated by their security operations team. So for example, one of the very dangerous commands would be a PLC stop. PLC is a programmable logic controller. It's the device that would control, for example, a turbine. And if someone sent a PLC stop command, that would stop operations. And it very rarely happens in real life. So that's the type of alert that you would want to forward to the SOC so they can investigate whether it was malicious or a legitimate activity.
Okay, and on this slide you have some examples of how the secure alerts looks like, how the vulnerability management information looks like, and the assessment discovery of network and topology mapping.
Yeah,
right?
Let me start with the asset discovery because often that's the very first thing that customers see. So within a few minutes of connecting the appliance to the switch, it starts building this map. And for many organizations, it's the first time they're actually seeing what devices they have, how they're connected, and how they're communicating with each other. Because many of these facilities were built 10 or 15 years ago, and devices were added and taken away over time, and the teams don't really have this level of visibility. So obviously, from a security point of view, you can't secure what you don't know you have. So this is usually a very big first step, and then you can, deep dive into any of these devices. For example, here, the PLC East, and find out, oh, this is a PLC, that's the type of device. The vendor of this device is ABB, which is a well-known OT automation vendor. It's using this protocol, DNP3. It has this IP address, this MAC address. So it's very detailed information about the devices. And then the next thing you want to know is what vulnerabilities do I have? And you can't fix all the vulnerabilities. These devices often are unpatched. So how do you fix the most important vulnerabilities based on risk prioritization to prevent any material impact to your organization, such as a safety incident or a major production line going down? And then finally, you monitor the network for something that could be malicious. In this case, the firmware was changed. Again, this could be a legitimate activity, or it could be an adversary downloading a backdoor into the firmware, and you'd want to know about that as well. And there's a full range of alerts that are detected by the system. For example, as part of a zero trust approach to your IoT and OT network, you'd want to know whenever an unauthorized device was connected to the network, or whenever there was an unauthorized connection to the internet. So these are all aspects of implementing zero trust. Often we talk about identity in the context of zero trust, but when it comes to IoT and OT devices, it's more about detecting unauthorized or unusual activity and then mitigating that as quickly as possible.
So these are out-of-the-box analytics that we have for Azure Defender for IoT, right?
That's correct, because what the system does is, even though it shows a picture of the network topology typically within a few minutes, it spends about a week learning what is normal and not normal on the network. It builds a baseline of normal activity. And rather than using generic baselining algorithms that were designed for IT networks, which have quite different behavior, they tend to be very non-deterministic. In these networks, it tends to be very deterministic. The same machines are usually talking to each other on the same types of schedules. So the algorithms have been specifically designed to very quickly build a baseline of what's normal and very quickly identify what's not normal. So with a minimum of false positives and false negatives.
Great, Phil. That's very cool. Now I'm gonna show a quick demonstration here. Before we go to the demonstration, can you just summarize what this demonstration is about?
Yeah, so in this demonstration, we're going to see how the network starts building a picture of the network topology and the assets. And then the person doing the demonstration, Paul, is going to show some alerts, and he's going to show something called the timeline of alerts, which you also see in this screenshot, where you can see which alerts came in based on the time they came in, which can be very helpful when you're doing investigation as part of an incident response or when you're doing threat hunting.
Great. So let's move on to the demonstration, and we'll be right back.
If we look at the asset map on the platform, what you need out of any solution and to implement any security policy is to understand what's in the environment. So in this case, we've discovered a PLC, and you can see from the blue line that it has a connection to an HMI. So we've picked out that there are PLCs in this environment. We've picked out that there are HMIs in this environment. And using our patented machine-to-machine analytics, we can very quickly understand how these devices are interacting on the network. So now I can see that my two devices are there, they're communicating, and they're using a specific protocol to do this. So some of these environments can be up to 20 or 30 years old, and where they've grown through additions and devices have been removed, and it's even worse if a company has grown through acquisition, we really do need to have a detailed idea of what's in this environment. And that doesn't just include the devices that are there. We need to understand from an inventory point of view, things like the model number, the serial number, what type of device, what version it's running. This then enables us to leverage the intelligence within the platform to start associating CVEs and vulnerabilities with individual devices. Then, again, using the threat intelligence within the platform, we can start building up an idea of what's wrong in the environment. Hopefully nothing, but in this case, we can see, for example, our malware engine has picked up a suspicion of NotPetya. Our protocol engine has picked up an illegal protocol operation. We've got unauthorized PLC configuration reads, and we've got a PLC stop command being sent. Now, any of these can take down a production line and potentially then be revenue impacting. So it's something that we need to be aware of. And by integrating this back into Sentinel, we can provide your SOC analysts with native incidents to help them remediate the issue a lot faster. So in summary, the first part of any security policy will be to find what's in the environment and what needs protecting.
All right, Phil. So this was a pretty cool demo. I was wondering about the threat intel that is utilized to generate those analytics. How we leverage our threat intelligence for that.
Yeah, so the alerts are generated through a combination of the native behavioral analytics, which look at behavior, so perfect for anything like a zero-day attack, living off the land tactics, fileless malware, stuff that doesn't rely on known IOCs. But to rapidly detect known IOCs, we have an in-house group of threat intelligence experts called Section 52, and they're continuously monitoring for IoT and OT vulnerabilities, their reverse engineering malware, and that information gets sent in a continuous way from Azure to the sensors. And so, for example, recently we put out threat intel packages about the FireEye hacking tools, the Rebellion campaign, and the whole thing is integrated with our global threat intelligence feed. So not only do the sensors benefit from this specialized IoT threat intelligence, but also gets to benefit from all the 800 trillion signals we collect from across the ecosystem that Microsoft monitors.
Yeah, so since you are already on this slide, it is a very well-known slide from our audience. Can you just wrap up talking about how this solution fits into the bigger umbrella of our products?
Sure. So Azure Defender for IoT is part of the Azure Defender XDR, Extended detection and response, specifically focused on the industrial IoT infrastructure in your organization. And it also integrates with Azure Sentinel, which, as you know, is a cloud-native SIEM SOAR system. So Sentinel has all the benefits you would expect from a cloud-based service in terms of simplicity, scalability, reduced cost of ownership. But in addition, it's being enhanced with OT-specific capabilities, such as a deep integration with Azure Defender for IoT to receive information not just about the alerts, but the assets that were involved in the incident. It's benefiting from the threat intelligence we just talked about. And we're also building a set of specific SOAR playbooks, automated response playbooks, specific to IoT and OT. And you can see here, this is an alert showing an incident where first the PLC system, programming system was compromised, and then they used that as a launching point to install a backdoor into the PLC. This is an attack known as Triton. So it's very important to get the bird's eye view across IT and OT, and that's why you need a system like Sentinel. That's also why this should be in your SOC, because many of these attacks start on the IT side and move into the OT side, or they might start on the OT side and then pivot into the IT side. So you need that big picture view across both.
Yeah, I think that this is an excellent point. We've seen many situations where it actually starts on the OT side because there is not really a monitoring system there. We saw this back some years ago with SCADA moving from the OT to the IoT security. And by the time that lands on the IoT security and the threats detection were in place, it was already too late to remediate or do something else.
Exactly.
Excellent conversation, Phil. Thank you very much for your time. Thanks for demonstrate. Thanks for the slides. And if someone wants to try Azure Defender for IoT, there is any trial version or how that works?
Yeah, there's a 30-day free trial for up to 1,000 committed devices that you can download from the product page on Azure Defender for IoT. And that's a good way to get started.
Awesome. All right, so that's a wrap. Thank you everyone for joining again, Azure Security Center in the Field. Make sure to subscribe, share this video, and continue to support the show. Write down your comments about new episodes that you want to see, and we'll see you again next time.